Coming up on How Do They Do It? How do they build a fighter jet that can reach twice the speed of sound? How do Trappist monks use divine fermentation to brew beer of the highest order? And how does one of America's biggest car plants produce 250,000 vehicles a year, but almost no waste? We take you around the world to show you how, on How Do They Do It? Is it a bird? No, it's a plane. But not just any plane. This is the Eurofighter Typhoon, the pinnacle of military hardware. From its supersonic engines to the tips of its computer-adjusted wings, the Typhoon is controlled with cutting-edge tech. Constructed from some of the most sophisticated lightweight materials on Earth, and built using the most advanced engineering imaginable. So, how do they do it? Samlesbury, Lancashire. A place of rolling, verdant hills and rural tranquility. And the site of BAE Systems' colossal assembly plant, the UK home of the Eurofighter. Capable of air-to-air and air-to-ground assault, it is arguably the world's most advanced multi-role fighter jet. The man lucky enough to fly this jet for a living is Mark Bowman.
It's every boy's dream. I don't think a day goes by when you don't actually sort of pinch yourself about what sort of job you do.
For top guns like Mark, the key to winning any battle in the skies is a combination of speed and maneuverability. Speed comes from 2 turbofans capable of pushing the plane north of 2,400 kilometers an hour, twice the speed of sound. But it's the Eurofighter's agility that puts this bird ahead of the flock. Amazingly, it's designed to be naturally unstable, which makes it exceptionally maneuverable, enabling Mark to sidestep anything in the skies. The $100 million Eurofighter is the cutting edge of aeronautical engineering. Each plane starts with a fuselage made from carbon fiber composites to keep weight down and strength up. Inside, almost 50 kilometers of cabling provides fly-by-wire computer control of the foreplanes, flaps and rudder. The 3 fuselage sections are lined up by laser, ensuring this 16-meter-long plane is built to an accuracy of less than 1 millimeter. With the fuselage complete, the main wings can be brought in. To keep them light and strong, these are made from carbon fiber composites with titanium leading edges. Each weighs 900 kilos, but can support 130 times that weight, which means Mark can pull 9 Gs in flight. That's over 4 times a space shuttle launch. This plane is the product of an international consortium. The right wing is made in Spain, the left in Italy, and the fuselage in Germany and Britain. No wonder they call it a Eurofighter. The swept-back delta wings make this jet highly maneuverable at speeds over Mach 1. But it also makes it less controllable at subsonic speeds. So the Eurofighter is fitted with 2 smaller front wings called foreplanes or canards. These are the secret to the jet's eye-popping agility.
The maneuverability is absolutely vital. Combat aircraft, lots of G, you really want a level of agility that they can provide.
In flight, these movable wings are adjusted 50 times a minute. At high speeds and under intense stresses, these wings need to be super light and super strong. So they're built from one of the strongest metals in the world, titanium. The process of making super strong wings starts here. Each metal sheet is passed through this screen printing process. A stencil is first placed onto the metal sheet. As the machine passes over the top, it deposits heat-resistant material through the stencil and onto the titanium. The finished sheets are then moved next door to the furnace section. After getting suited and booted, the furnace is fired up. Inside, the sheets are baked under pressure at 950 degrees Celsius in a process called diffusion bonding. This fuses the sheets into one piece of metal. Paul Toohey is the man in charge.
The diffusion bonding process, in essence, sticks them 6 sheets of titanium together by heating that material up to a state where the molecular structure can start to diffuse together to make the strength of one piece of material.
Crucially, the heat-resistant parts that were stenciled on do not fuse with their neighbour. This means there is room for a gas to force through the parts that haven't been bonded, so the engineers can inflate sections of the wing to create an internal structure called an X-core. This X structure is extremely strong, but much lighter than solid layers of metal.
The more weight we can take out of the aircraft, the better. This process allows us to take a lot of weight out of the old traditional methods of riveting pieces of sheet of material together.
The X-core means the four-plane wing is lighter than if it were welded and strong enough to withstand a phenomenal 9G. However, even a minute imperfection could cause catastrophic failure in flight. So each is tested in this tank. By passing ultrasound waves through the wing, the computer checks each square millimetre for structural imperfections.
So this process allows us to ultrasonically check that component to make sure that it is defect-free before it goes onto an aircraft for flight.
Back in the assembly hall, the finished four-plane wings are attached to the plane. To distribute the forces placed on the four planes whilst flying at great speeds, they're mounted onto a strong frame that acts like a human hip joint. This allows the manoeuvrability that sets the Eurofighter apart from the rest. The skeleton of the Eurofighter is complete, so now it's time to add the muscle. This is provided by 2 Rolls-Royce-based turbofan engines, each capable of kicking in with 20,000 pounds of thrust. The engines are jacked up and carefully aligned. On full throttle, these can push the plane to over the height of Everest in under a minute. But incredibly, it's just 1 nut and 2 pins that hold it in place. After 42 weeks of state-of-the-art engineering, the plane is almost complete.
This is the end of a long production line. When we're finished in here, they send the aircraft to spray shop where it gets painted, and the pilots take it out and put it through its paces, basically.
In the paint room, layers of a secret stealth-enhancing undercoat are topped off with military grey. Finally, it's time to hand over the finished Eurofighter to test pilot Andy Blythe. Andy is going to put the new jet through its paces with a quick 800-kilometre flight.
Tarnish 9, runway 25, clear for takeoff. Surface wind 300 degrees, 7 knots, overrun cable up.
The control tower clears the runway. The company's resident Falcons have already cleared the skies. Thanks to a little extra lift provided by the 4 planes, he takes off in just 400 metres. With pedal to the metal, the Typhoon can eat up the 160 kilometres between South Lancashire and Scotland in the time it takes to brew a pot of tea. All thanks to some of the most advanced military engineering on Earth, or in the sky. Still to come, how do Trappist monks brew divine beer to their own secret recipe? And how does a giant roll of steel help one of America's biggest car plants to roll out over 250,000 cars a year? Join us after the break to find out how on How Do They Do It?